Welcome to another episode of Cyber Secrets. In this episode, we're going to discuss forensic imaging, and some of the tools we're going to use are going to be free open source tools found on Linux. Computer forensics is a term that is used in many industry segments, from criminal investigation to incident response to even data recovery. There are three types of forensically sound copies. The first is called the wrong way, so don't do it. The second is a logical copy. This is a method that just gathers allocated data for later use. For example, the copy command, or copy and paste utilities that are logical copy tools. You cannot recover deleted data with this method, since the deleted files fall under the unallocated space or free space. Other terms for logical copy include sparse copy or even backup and archive. The third is called physical copy. This copies both the allocated and the unallocated data. In other words, it copies all data, bit by bit, and beginning to end. This is an identical clone. For example, DD, DCF-LDD, FTK Imager, and other forensic software contain this ability. The term for physical copy also includes bitstream, bit-level, image, and clone. When making a forensically sound copy, it is important to have a physical write blocker. What a write blocker does is prevents you from altering the data and protects the disk from being destroyed by the operating system. In this case, I have a USB thumb drive that I want to connect and make a copy of. First, though, I need to connect it to a write blocker. Then, I connect the write blocker to the computer. As you can see, it is now just popped up on my screen. In this new window, there are many files that are easily recoverable. For example, I'll click on a couple of them, just so you can see. Graphic, perfectly recoverable, and another graphic, perfectly recoverable. As a reminder, if I were to copy any of these files to another data area, this would be called a logical copy. This method is not going to be able to recover deleted data. Many of the Linux commands are CLI, or command line interfaces. The tool that I like to use is DCF-LDD. This program is an upgrade from the original DD command. Because it can also create a hash if needed, that's a huge benefit. It also allows you to see how much data has been copied so far. If you type in the command man, short for manual, DCF-LDD, you'll get a huge list of how the program is supposed to run. If you type in DCF-LDD --help, it'll give you another list on how to properly use the syntax. Now to make the bitstream copy. First we have to find the drive. In Linux there are several ways to find the drive. The drive is not found by just looking for the name, in this case recovery-dr, or by consulting your Magic 8-Ball. The first method we're going to talk about is df, or the disk free command. Notice the bottom two sections, /dev, /sdb1, and /media/recovery-dr. So the actual drive is /dev/sdb1. The recovery-dr is the mounted media. The second method we will use is dmesg, or the kernel messaging. So you type in dmesg, pipe, grep, and then sd. This is going to focus solely on the SD drives that are connected to the system. If you look at the very bottom, you will see FATFS, which is SDB1, with the first partition on the second disk, or SDB. The third method we'll use is the basic dir, or list in Linux. So dir/dev/sd for all the drives. If you take a look, you see SDA, first drive, SDB, second drive, and SDB1 is the drive that we actually want to copy. Now that we have the drive, we can now begin the forensically sound copy. We're now going to type in dcfldd. IF is for input file. This is your source. And then we're going to put it equal /dev and /sdb. SDB would copy the physical or the entire drive. This is 100% of the drive. This grabs master file table and partition table and everything on the drive from the first sector to the last sector. Adding a 1 would copy the logical drive. This is also known as the partition or volume. You would not copy the master boot record, the partition table, the gaps in the partitions, or any other partition with the logical drive. But in this case, we want to only copy the volume because the way we want to mount the drive to recover basic data here in just a minute. Now let's choose the destination, output file. This is going to be in temp file, so it's easy to find, and we're just going to call it USB. Imaging is copying bit by bit. This takes a long time. So during this process, we're going to fast forward it a little bit, but this would be a great time to get coffee, go to dinner, possibly even go on vacation, depending on how big the hard drive is. This took so long, I actually decided to start a movie if you see the top left-hand side. But the benefit in the command line window is you see the amount of bytes in and the amount of bytes out. To verify our handiwork, we're just going to do a simple ls, again same thing as the dir, and look at the files in the temp folder. We just created that USB file, and that's a bitstream copy of that thumb drive. Now, we're going to take a look at it in a few places. However, the first thing we're going to want to do is mount that drive. The easiest way to mount it is by creating a folder, and we're going to put it into the media folder. Some distributions of Linux allow the things in the media folder to automatically be seen on the desktop, just like that recovery-dd. So this one we're going to call it media USB file recovery system copy, or forensically sound copy. Notice it did not show up on the screen because we still need to mount it. We're going to mount the /tmp/USB and then space media /USB forensically sound copy, or FSC. And if you notice in the left-hand side, it should be popping up. There we go. Let's go and double left click on it. And then we're going to take a look at all the content inside that drive. Again, remember, this is the DD image. This is not the USB thumb drive. And as you can see, it looks just identical. Recovery-DR and the DD image. At this point, you can do a logical copy just by highlighting everything and copy and pasting it into another folder, or we can use other forensics tools on that DD image that we just created, such as doing data carving or other sorts of analysis.